So the first thing you should do when you decide to drill your own water well is to go to check the local codes in your area and see what's required. Some places require permits, some places don't require anything at all, some places don't allow it at all. So you just need to go to the local courthouse and talk to somebody there. But make sure that you make it clear to them that you want to drill your own well for yourself on your property, because it makes a big difference. Because if you're drilling a well for somebody else, then you have to have a license and a permit and all that other stuff. But sometimes in some states and counties, you can drill your own well for yourself without any hassle. Sometimes the inspector will want to come watch you drill or just watch you case. Sometimes they'll have different rules. They're different in every state. I can't give you specific advice on that because it's just too much to know. So just go to your local courthouse and find out for yourself. Once you've done that, you need to go to the call before you dig people, whatever the number is in your area, and make sure you don't have any underground lines that you're going to run into, like electric, gas, water, things like that. Obviously, that would be a bad thing. Make sure that you're not too close to a septic tank because, again, obviously, septic tank field lines run down your well. That would be a very bad thing for your water supply. So just mostly basic common sense stuff like that. Don't put it downhill from your barn where all the runoff from your barn runs right into your well. And if you do have to put it someplace like that, you have to take extra precautions to make sure that the well is really well sealed and grouted and so on. But we'll cover that later in this video. And that brings us to the question of where to drill your well. Now, contrary to popular belief, water does not run in narrow rivers like this wide here and over there. There'd be no water at all. It doesn't work that way. Water seeks its own level. In most places in the world, every place that you drill under your property, you're going to find water at roughly the same level, depending on the lay of your land. Right here, I'm like 5 feet higher than I am right there, which means obviously I'm going to have to drill 5 feet deeper to find water here than right there. Some basic stuff like that. There are some minor exceptions, but for the most part, anywhere you drill on your property, you're going to find water at roughly the same depth. So given that fact, which I've verified many times in my own wells, and which I'll explain in more detail in another chapter later on how to understand the geology of the water underground, given that fact, you want to drill a well where it's convenient for you. So in the summertime, you should drill in the shade, where it's cool. In the wintertime, you should drill in the sun, things like that. Also, you want to drill a well where it's close to power so that you can run the pump afterwards, and where it's close to a water line so that you can access your house or your yard or whatever it is you're going to use your well water for. So that's how we decide where to drill. How deep to drill is a separate question. Now, there's several ways you can determine a general idea of how deep you're going to need to drill. One thing I can tell you is that of all the kits that I've ever sold, I've never had a single customer who drilled a well to 100 feet and didn't find water. Now, that's significant because a lot of places you'll hear that you have to drill 400 or 500 feet to get water. And that's really not true. You will find a good supply of water at 500 feet, that's true. But you have to remember that professional well drillers get paid by the foot. So it's to their benefit to drill as deep as possible, whether you need to or not. I hear stories about this all the time from people who got shafted by well drillers, and they didn't really need to drill that deep. So bear that in mind when you hear that you're going to have to drill such and such a number of feet deep. That said, professional well drillers are required to log all of their wells at the local courthouse. So go to the local courthouse, ask to see the well logs. This will give you a general idea because they're going to say, drilled 30 feet through clay, hit 10 feet of rock, drilled 10 feet through rock, hit some water, drilled 50 feet, hit some more water, things like that. Now, you can't take these as gospel because they kind of make stuff up because they're not really down there. They're just mostly guessing, and it doesn't really matter that much to them anyway. So you can't really rely on it too heavily, but it will give you a general idea. A lot of times you'll hear, hit first water at 35 feet. Now, that water may not be the best water for you, but a lot of times it can be pretty good. Some of it may be sulfur, but you may have sulfur at 75 feet or 150. You never really know what you're going to find until you get down there, but this will give you some vague idea. Another thing that you can do is go to your neighbor, if he has a well, if you know somebody who has a well around you, and ask to drop a float into their well. Now, that basically involves taking a pill bottle, putting a little weight in it, tying it to a string, and dropping it in a well. You drop it till you hear a plunk, you pull it back out, you measure the string, and that tells you where the first water level is on his property, which if it's close to yours and in similar terrain, will give you a general idea that you need to drill so many feet before you hit your first water. Once you know that, you need to go an absolute minimum of 20 feet beyond that in order to get enough water supply that your pump doesn't run dry every time you turn the faucet on. It's much better if you go, say, 50 feet past your first water level, just to be on the safe side. But these are just general recommendations. So before you start drilling your well, it's helpful to understand how the water got down to where you're trying to get it back out of. Now, there is deep aquifer water that's been there for thousands of years, and no one really knows how it got there. It's just there. And sometimes it runs in weird ways with channels and pockets and things like that. But for the most part, we're not worried about that because we're working with surface water. Now, surface water is by no means bad water because this is what people have lived off of for thousands of years because they couldn't drill aquifer wells. But they drilled wells by hand all over the areas, all across the U.S. with 30, 50 feet deep by hand, and that supplied all of their needs. Now, the water levels have dropped some in recent years in a lot of places due to Ozarka and big water companies like that pulling water out. But for the most part, water level is still less than 100 feet most places. Now, when it rains out here, water hits the ground, and some of it runs off to the rivers and lakes and so on. Some of it evaporates, some of it is used by the trees, but a good chunk of it keeps going. And it goes down through the sand, and if you have a pool, you know that even 2 or 3 feet of sand is enough to clean water pretty good, because a lot of pools use sand filters, and just running through 2 or 3 feet of sand is all it needs. And then it gets down to clay. Now, clay is a much finer filter. It will eventually work its way through clay, but it takes a lot longer time. And so the clay tends to trap the water in these bowl-shaped pieces of clay, or it runs downhill a ways to another piece of clay until it stops. Water seeks its own level, even through sand. So it keeps going. Eventually it gets through the clay, which is a really good filter, and so underneath that clay, the water's going to be a lot cleaner. And so underneath that clay, maybe another layer, and then another layer, interspersed with layers of water and sand or rock or other things like that. So you're going to pierce a number of these layers. Now, between, say, a clay layer at 30 feet and a clay layer at 50 feet, there may be some iron deposits, and that's likely to make that water full of iron, which will make it taste bad, make your house all stained with little rust spots and stuff like that. Or you might have salt in it, or calcium, or whatever. But each time you hit through a different clay layer, you usually have a different type of water. So if you don't find good water at 30 feet, 50 feet, or 80 feet, you can find it at different places. You may have to drill different wells to do this, but just remember where the clay layers were and write them down as you're drilling, and that will help you later understand what water you're pulling out of. So the general point of all of that is you should plan to drill between 50 and 100 feet, and there's a good chance that you'll be in the 90% of people who will get good water at that depth. Now that water may not be perfect, but you can drill another well later in a different spot, deeper or shallower, based on the information and the experience that you've learned from your first attempt. You can drill deeper. I've drilled 210 feet myself, and I think you could even go deeper than that, but it gets more difficult at deeper depths. We'll talk about that more later. So I try to encourage people to stay at less than 100 feet on their first well if at all possible, because you have a much greater chance of success in that kind of a well than you are going deeper your first time. It's always best to choose a spot that has plenty of space to work in, because you're going to need to drag several hundred feet of PVC pipe in and out of the well, depending on what you're drilling with. And so having a nice big area like that is really nice. It's not strictly necessary. You can drill in the woods. You can drill in even like 10 by 10 lots. I've heard of people who did it. But you're going to make it a lot more difficult on yourself. So if at all possible, try to get a place where you have at least one clear 8-foot wide path that you can drag stuff out in. That said, it's time to start preparing our site. One of the first things that you want to do, pick the actual spot you're going to drill, which I've chosen as here, and you're going to drill a hole here with the post hole diggers as deep as you can go. Now it's going to be about a 6-inch in diameter, and the more you can get out of it with the post hole diggers, the less you have to get out with the drill. And it's going to be easier doing it this way than with the drill. And it helps to give the drill a straight shot getting down the well if you have one of these. Otherwise, you're kind of starting on the surface and it's a mess. So drill your hole as deep as you can with post hole diggers. I'm going to do that here in a minute. Back over here we have our settling pond. Now we need this because when you pump water up out of the well, it's going to have mud mixed with it, the tailings that you're drilling up in the bottom. They're going to go someplace, and if they just run right back down your well, then it's just going to keep recycling the mud, and so you're going to have trouble getting stuff out of your well. So I've dug a hole here with the front end load on my tractor. I've done it by hand in the past, but I have a tractor, and so I'm going to use it. The water's going to come over here and stand in here. The settling will happen, and then the water will run off the top back down in here through a pipe, which we're going to install right in here. So every so often I'm going to have to come back and dig that out with a tractor or with a shovel, depending on what you've got. Now, you're going to lose a little bit of water as you're drilling through there, but the most of it's going to go back down here. Because as you drill, you're going to be stirring up mud and sand, and that mud is going to stick in the walls here. It's going to absorb some of that sand and kind of plug the holes in it. So you won't lose anywhere near as much water as you think you will in this pit. But if it really bothers you, you can lay a piece of plastic down or a piece of rubber matting or whatever, something to kind of keep the water from being able to drip out. You have to be careful of that later when you go to shovel out your mud, which you'll be doing a lot. So balance that against how badly you need your water versus how much hassle it's going to be to work around the plastic. I usually don't use the plastic. That said, you need to make sure that your settling pond is either level or slightly uphill from your well drilling hole, because you need the water to be able to run out of there by gravity downhill and roll back into the well by itself. And that means you need to have roughly similar depths here. So it's going to fill up, run out the top over to here through a 2-inch PVC pipe. The pipe needs to be however long this distance is between there and there. In this case, it's about 12 feet. 6 to 12 feet, anything like that is fine. You could do a lot closer if you needed to, but for me, I wanted it a little farther away. So now, since you don't need to watch me do this, I'm going to drill that hole, and I'm going to dig a ditch here. I'm going to put a 2-inch pipe in it. So I've dug out this ditch, and I've made it so it slopes downward towards the hole, because you need to have at least a couple inches of drop over 10 feet. Otherwise, it's not going to want to roll downhill. So take a level, put it on here. Yeah, got a good drop on it. Check it 2 or 3 places along here to make sure, but it's right in this case, so I'm going to go ahead and go with it. I've made it so it's about 1.5 inches, 2 inches below ground level on the pit side, and about 6 inches below ground level on the well side. Now, these dimensions are not that important, just as long as it goes downhill, that's all that really matters, because we're just taking water that settles into here and running it back and down the well. That's all we're doing. So up or down doesn't matter as much as long as it's a good downhill slope. So as you're drilling, you're going to be drilling through roots. You're going to pick up grass and stuff from your pit. Leaves are going to fall into it, things like that. And it's best not to get that stuff back down the well because it's just going to recycle and could get clogged up in the drill and just cause problems in general. So to get rid of that, we put a screen around this end of the pipe so that nothing can get through there except stuff that's smaller than the screen. So you may get a little bit of kind of a dam around this with the flotsam and stuff that's floating, but you can always scrape that away a lot easier than scraping stuff out of the well. So take your pipe, and you put 4 corners to the pipe like this, and then pull it up a little bit, and just wrap around like this. Now you can use a hose clamp, or you can use duct tape, and you're going to wrap this on. You don't want to be right up against the pipe. You want to have like this pocket up here so that you have a lot of different places for water to get in around the junk, because it's going to clog up if you're not careful, probably even if you are. I've dug my pilot hole with the post hole digger, and I got about 3 feet down, and I hit this really sandy clay. It's kind of a pain to drill through with this. The drill will chew it up. So I'm just going to stop there and let the drill do the rest. You need to get at least 3 feet down, preferably 4 or even 5 if you can. And if you hit a rock while you're drilling at this stage, go to the time to drill the rock out. Because if you try to do that with the drill, you'll be allowed a lot longer than you would be if you just take the time to get it out with one of these. If you keep running into rocks, drilling a well may not be a great idea because while we can drill rocks, it's really slow, and so it's a lot easier to get them out with something like this than it is with a drill. Now, if we leave it like this, we're going to have a little bit of a problem because water comes through that pipe and pours back down this hole, and that's what we want to happen. The problem is it comes out at a fairly good speed, picked up on that slope, and tends to come out, shoot across here, and wash out a nice little pocket on this side of the well. Now, if you're just drilling for 1 or 2 days, that's not long enough for it to really become a problem. A week or two, it starts to become annoying, and after a couple weeks, you tend to have a hole big enough to drop a tractor into. So we need to control that erosion and need to make it happen lower in the well, or preferably not at all. One way to do that is to use a temporary casing. Now, this is a piece of 6-inch pipe. I've used this one many times, which is why it's got these holes already in it. Once you've dug your pilot hole, you drop it in like that, and then you position your hole so that this comes down into here. So we're just going to dig down here, mark it on top of this pipe, drill a hole that's big enough for a 2-inch pipe, which is 2 3/8-inch hole. You can do it in several barbaric ways if you need to, but basically you just need to get that pipe into this pipe so that water comes in here instead of splashing on the dirt, will splash on the far side of a PVC pipe, which would take several hundred years to erode. So, we're going to cut this off and put it in there. However, if you're going to drill for a 6-inch casing, you have to drill an 8-inch hole. Now, obviously, an 8-inch bit is not going to fit in a 6-inch pipe. So, you're going to have to remove this later. If you're not going to drill for an 8-inch casing, if you're just going to go for 6-inch, then it's best if you put some concrete around the outside of this pipe. Because what happens, when this sets in there, you put some dirt back around it, you're going to drill a hole down there, and you have water, you have air bubbling coming up around the water, especially the first 10 or 15 feet. And that means that all the time you get this water coming up around the base of this pipe and eroding the dirt that you've got packed up against the outside of it in your hole. What that means is that after you drill 15, 20 feet, generally your pipe is kind of loose in there. You have to wedge it in, or it tries to fall in the hole, or other things like that happen. So it's best if you're going to use this, and if you're not going to drill an 8-inch hole, it's best to put some concrete around the outside of this, at least down in the hole around there. It won't take very much. Half a bag of Sackcrete will be enough, and that'll anchor it in this position. So if you dug a neat hole with your post hole diggers, which is just a little bit bigger than this one, you won't have to do with concrete, and it'll help hold it stable. You might still have some erosion problems later, but it's going to be a long way down the road, and you can worry about that at that point. But if you do that, it'll be harder to pull it out of the ground, so think about that before you do it. If you have a really bad problem, you can go ahead and just put a pad around the base of your well, a concrete pad, because you're probably going to put a pump house here at some point, and so having a little 3-foot by 3-foot slab around here will greatly stabilize this system, make everything solid and clean around the well, and you're probably going to use it anyway, assuming the well comes out and gives you good water down the road that you need to pump. So you can drill without one of these if you're going to be drilling for a short period of time, a really easy well, or if you're drilling in a really solid substance like clay that's not likely to be eroded very badly by the water. But overall, I recommend using one if you can. So I've cut it off and I've drilled a 2 3/8 inch hole in here, which is the size of 2-inch pipe on the outside. Shoving it in there, putting the pipe inside the hole. It's exactly the size, and so it kind of has to be encouraged to fit in there. Okay, that's in there. You want it to be in there about a 1/2 inch or so you have about a 1/4 inch on the edges and a 1/2 inch in the middle. You don't want to be too far in, because otherwise the bit will catch it on the way down. So the other advantage this gives you is that it gives you a very clear line which you can use to gauge your progress while drilling. So in other words, if you hold the piece of pipe that you're drilling with up against this and put a magic marker line on it, and then 5 minutes later you see the line's a 1/2 inch down, it's a very easy way to tell that you are making progress. Whereas if you're just walking off the dirt, it's kind of hard to tell sometimes. So that's another good reason to have this in here. So next we do the catch barrel. Now the idea of this is that the water is going to be coming out of the pipe mixed with air as you drill. It's going to be coming out like that. And so you need it to go and catch someplace, because otherwise it's going to go all over the yard and be hard to control. So by having it come out here and go up in this barrel, it all stops and then it runs back here at a much slower speed in a controlled area. It needs to be setting uphill so the water will go in there and roll back out. I've got a hill behind here, so it works out well for me. You can build it up with some dirt if you need to. And I'm going to put some dirt on this side as well so it doesn't roll back and forth too much, kind of stabilize it. And because the pipe is going to be coming out here like this and going in there, we're going to have an elbow on it. You'll see in a few minutes. And to keep that from bouncing right out of here the first time you hit water coming out of it, take a stake. This is just an ordinary concrete stake. You can make your own, as I did. And drive it in the ground. Now, we're going to duct tape our pipe to this so that it doesn't vibrate in and out of here all the time. And now the next step is to cover up this 2-inch pipe so that we can walk around here without tripping. And if you're going to put concrete around your 6-inch temporary casing, now's the time to do that. And then we have it all flattened out, and we'll move on to the next step. So you'll have detailed instructions on how to make the drill and all the bits and everything on the end of this video. For right now, I'm going to assume that you've either already done that, or else have bought the kit from me, and you've gotten this in a package already. Either way, your drill is going to look like this. This is your drill down here, the motor's inside. This part here doesn't come out of the plastic. This has been heat shrunk on there. It won't be coming out very easily, if ever. This is the expansion chamber. This plastic part here is what we call it, because the air comes out here, goes up, and it expands because it's suddenly under a lot lower pressure. That expansion creates a vacuum in these air holes. This sucks dirt and water from the outside around and blows up the pipe. This is, of course, your air hose, and this attaches to more 3/8 air hose up the pipe. This will attach to 1-inch pipe as it goes up the pipe as well, and that'll also be your drill stem. Now, you're going to get one of these bits if you buy the kit from us, or you're going to make one. This is a 2-wing bit. We call it a general purpose bit, because it's a pretty good bit for doing basic, simple stuff like sand and some clay, but it will wear very quickly if you're in rock. So you're not going to want to use this kind of bit if you're going to have a very hard well to drill. But for most people who are drilling a relatively easy, shallow well, this is the bit that you're going to go with because it's going to be a lot cheaper. We have a much better quality bit here, which lasts a whole lot longer and is designed for working with clay and rock and will give you a better quality drill. However, this is a lot more expensive. So if you're going to drill a harder well, you're definitely going to want to get this bit. Now if you make it yourself, it's going to look a little bit different, more like this, because building them this way is going to be a lot easier for you to make than it is for you to make one of those kind of bits, because I buy them in bulk and I have them cut for me. So this is what I sell. This is what you would be making, or you can also make one like this. And then we also have other sizes that we sell on the website right now. This is 3 3/4 for drilling a smaller hole. This is 8 inches for drilling a much larger hole for drilling for 6-inch casing. And in any case, you're going to drill your first hole with this, because this is going to let you put 4-inch casing down. And this is almost always going to be your best option. So if you buy the drill from us, it's probably going to come shrink wrapped. And the purpose of that is, once we test these, we put air tool oil in them, and the internal parts of the motor will then stay lubricated. However, if air is allowed to get in and out of them a lot, then they're going to dry up over time. And there's nothing really wrong with that. The problem is that over time, they're just going to get sticky. As they get sticky, the little fins that make this motor turn don't come out as easily. And so your motor may not start when you turn it on. It may not run right away. Now you can fix that. Air tool oil in the back of the drill is one of the fastest ways to fix that, but we'll cover that more later. For right now, it's going to come in that cellophane wrapper, and you're going to want to keep it in that as long as you can. Now, a day or two out of it is not going to make a big deal. But if you're going to be out for like a couple of months, best to leave it on. And if you're using your drill, you stop for a while, or for whatever reason you don't get a drill when you thought you did, stand your drill up like this. You'll find there's a little slot in the back where the exhaust air comes out. Put some air tool oil in that, a bunch of it, until it starts to come out the top. And then twist your motor a little bit like that. And that's going to get the air tool oil circulating around through the motor. Leave it setting like this, and as long as it's got that oil bath in there, it's never going to dry out. So for long-term storage, either that or shrink wrapping it, or even both, is going to be the best thing to keep your drill ready to use when you take it out of the box again. So once you've got all that set up, first thing you're going to do is you're going to take your drill and you're going to glue it on to one 20-foot stick of 1-inch thick wall Schedule 40 PVC. So we're going to go ahead and glue the first piece on. Now if you do this right, you should be able to put at least 2 or 3 different pieces of pipe on this one stem before you ever get close to the expansion chamber here. Always use cleaner and do a good job with it when you're doing this, because this is not only going to be holding pressure of the tailings coming out, it's also going to act as your drill stem, which means that if one of these joints is bad, your drill is going to be putting a lot of tension on it to do like this. You're going to be coming in and out of the hole a lot. It's going to be doing this number. It's going to be putting a lot of stress on those joints. And this is your only real lifeline to the bottom of the hole. So your air hose isn't going to be much to pull on. So if one of these things goes bad, it needs to not go bad. So clean it first, get good joints, and you'll never have any problems with it most likely. Now, another thing you need to remember not to do under any circumstances is to use couplings. Couplings are really, really short. An overall coupling length is about 1.5 inches, which means 3/4 inches of each side of that is all that you get to glue onto. Now you can see this bell here alone is about 2 inches, and that's one solid joint. That's going to be a much better quality joint than you can ever get out of a coupling. See, that kind of a joint won't be coming off. The really short ones you get on a coupling are not good for well drilling. So under no circumstances, use couplings. Now, I'm going to show you a way that you can repair a pipe if it breaks, or join pieces if you don't have bells on the end of the pipe by making your own bells. We'll cover that a little bit later. For right now, no couplings. So I got one piece of pipe glued on, and that's all we're going to put on for right now. The reason being that the way the air pumps is it has to have water around the pipe, and keep the hole full of water, and you have water in the pipe, air comes up the exhaust here, goes back up this pipe and comes out the top. Now, the deeper you are, the more water pressure you have above the drill, the more efficiently that's going to pump. We'll revisit this theme several times, but for right now, the point is that until you're about 20 feet down, you're not going to be able to blow water out the top of this very well. When you do, the more pipe you have on here, the deeper you have to be to make it pump efficiently. So before you can pump air and water through 160 feet of pipe, you've got to be about 30-35 feet deep. So it's best if you start with just one piece of pipe, which considering the length of the drill and the bit, means you'll be about 23 feet deep before this is in the ground. And that's where you're going to stop, pull the well out, put another piece, one more piece, making your pipe about 43 feet long, and then you're going to drill down with that. By the time you get down to where that's getting close to being in the ground, you'll be pumping really well, and you'll be able to attach it all the rest of your pipe all at once, and then you'll be using it all together for the whole rest of the well drilling. We're going to take the bit off later, but for right now we're going to screw the bit on, just enough to hold it there, because what we need to do now is get some marks on the pipe. It's very important to know how deep you are, both for your own morale and to just keep a general idea of how deep you're going. So take a tape and a magic marker, and you're going to want to measure from the bottom end of these fins, that's the end away from the drill, because this is going to be the bottom of your hole, effectively. So you'll probably need somebody to help you with this. I'm just going to do the first one myself. Measure down here, put a mark at 5 feet, like that. And do that at 10, 15, 20, 25, etc. When you do that, you want to come around and put a line all the way around the pipe, because you never know which side of the pipe is going to be facing you. No matter what side you start with, it's going to rotate as you drill. And then put a nice, clear 5 above there, so that you know how deep you are. We're going to do it all the way up the pipe. Now, we only have one piece of pipe joined together right now, but we want to go ahead and mark all of it. So we're going to put our second piece of pipe out here at the end of the pipe here. We're going to lay it where it's going to connect together. So it's going to be like this. When it's glued together, it's going to overlap about 1.5 inches here because of the bell. So when it's glued together, we want it to sit right like that. So now when we run a measuring tape from down there all the way out here, it's going to be the same as it will be when we're done. And so that's going to let us get a very accurate measurement. We're going to go ahead and measure the entire pipe and mark the entire pipe every 5 feet down to the depth at which we expect to go. In this case, I'm going to measure it to 100 for right now. I'm going to go deeper than that, but we're going to start with 100. So with that done, we're going to hook up the air hose to the drill. Now, I've Teflon taped it. All your joints should be Teflon taped or puttied so they don't have any leaks in them because you don't want to lose any more air than you have to. And it's going to screw together like this. But before we do that, since various types of insects have a habit of building nests inside of hoses, we need to turn it on and make sure it's all blown out before we hook up to the drill, because a little bug nest blown into the internals of the drill will require you to dismantle the drill and take it apart and fix it before you ever even use it. So make sure it's cleaned out beforehand, because there was no filtering after this before you get into the motor. Now when you blow it out, it's going to sound like this if you have decent pressure. That is about 70 psi coming out at the drill. Now that's a little lower than I like. But when you're running through air hose, what happens is the smaller the air hose is, the more friction there is inside of it. And friction does affect air. So if you're running through, say, 150 feet of 3/8 inch air hose, you're going to lose a significant amount of pressure before you get to the other end of it. I will demonstrate that here in a minute. 3/8 air hose is the minimum that we recommend to be hooked up to the drill. You can get by with 3/8, but I recommend 1/2 inch for a better performance, because you're going to lose 25 psi probably between the regulator and your drill, which means you're going to lose a certain percentage of performance, because this drill runs best when it has about 90 to 100 psi actually getting to the drill. So if you can afford it, running 1/2 inch air hose all the way down your pipe, hooking up your drill at this point, adapting the 3/8 here, is going to give you a better performance. However, most people are not going to have the extra air hose laying around to use, and so you're going to get 3/8. And so that's what I'm going to drill this well with, because it'll work. It's just not quite as good. Now, I've blown this out, and I've Teflon taped it, so I'm going to go ahead and screw this together and tighten it down. The next step is we're going to tape the air hose to the pipe. Now, if you don't do this, then you're going to be pulling the pipe up and down, and your hose is going to wind up getting kinked, a little bit more. It's going to stay down each time, and you're going to wind up with it wrapped around the drill a bit, and then that's going to cause a lot of problems for obvious reasons. So, every 5 feet, we're going to duct tape it to the pipe. Now, duct tape is going to wear as you go in and out of the ground, because you're going to have rocks and roots and pipe and other things like that that's going to catch on every time you go up and down. So, if you don't use good quality duct tape, your duct tape will come apart after a couple of times in and out of the well, and you have to do this again. So, I strongly recommend that you buy Gorilla Tape or some good quality brand of tape that's going to last for the whole well, so you have to keep doing this. Another trick that we do is we tape it at the 5 foot marks. So that way, the magic marker mark is going to wear off eventually as well, just with the sand and the water washing past it and it's very slowly eroding it. So if you duct tape it at the marks, then you know that every mark that you hit is going to be on a 5 foot mark, which means if you can discern where the mark used to be, or even measure from the bottom again, you can then just remark the mark, and you don't have to do the whole thing all from scratch. So now, wrap it around, right underneath the mark, and you want to do about 3 wraps. Minimum 2, but 3 is good. We're going to do that every time we have a mark up to the first 15 feet or so. Now, for this first piece of pipe, we're going to need to have that last little bit flexible. You'll see when we start drilling why that's important. For right now, we're just going to put the first 2 or 3 tapes on here and call that done. So now for the next step, we're going to tape this up here so that you don't have a leak on it. But before we do that, before we get too much time invested in this all working, we need to make sure that the drill doesn't need to be worked on in case you've kept it in storage too long, in case your air supply isn't right or whatever. You need to make sure it's all set up before you put much more time into the setup. So I've got an air compressor hooked up. At this point, it doesn't much matter what the size of air compressor is, because you're only going to be running it for about 15 seconds anyway. Make sure there's no bit on it. And then I'm going to have it turned on over there. You need to have somebody here holding it, and that way it doesn't, jump and run and fall off. Again, no bit. It's really important. It's worth saying twice. So you're going to be holding this like this, and you can listen to how it sounds. So that's a good sounding drill. It's not as good as it can be for a 1/2 inch, but it's a pretty good sounding drill. You can drill a good well with that. Open it up. So now that we've verified that everything is working right, we're now going to go ahead and tape this up. You're going to use quite a bit of tape on this because there's a little hole around this hose, and air comes up here. It needs to be forced to go up the pipe, not through this hole. So we're going to try our best to close off that hole. When you use good quality tape, it's harder to pull off the roll too, so it takes more effort there. You want to put one good wrap all the way around where it touches the pipe here before you start up on the hose. And then you work your way up, overlapping yourself about half tape width each time. And you're going to work your way up about to the first coupling here. Pulling it tight as you go. Like that, and then follow yourself back down. You want this to be neat because as you go in and out of the well, you don't want this to snag on roots or rocks or things like that. So this needs to be as smooth as you can make it on your final wrap. That's a little bit of a bubble there, so we're going to pull it down tighter. Okay. So that's a pretty good wrap there, and very little, if any, air is going to be able to escape up through here. So that step is done now. So this is half-inch air hose. Now the air that you heard blasting out of that tube earlier came through this air hose and then went through another 150 feet or so of air hose to get to that. You heard how that sounded. That wasn't bad, but this is what it sounded like before it went through that extra hose. See, that's enough power to kind of push you back a little bit. And this is going to give you a much better experience running your well if you can hook it directly to this instead of running through that extra hose. And so that's why I recommend half-inch air hose, if you can afford it and find it, rather than 3/8, because it will work better. But again, people have been drilling it with 3/8 air hose for a lot of years now and have had very little problem with it. So it works both ways. This is going to be better. Now, next we're going to work on the oiler. If you just hooked up the air compressor directly to your drill, it would run fine, but only for a little while, because inside that motor there's some fins that run around in a circle really fast. Without oil to lubricate it, those are going to dry up, start getting really hot, start melting, cracking, doing other really bad things. So you have to have oil running in it all the time. Now you may be able to get by with 15 or 20 minutes without oil, but if you run for any length of time, you will have trouble with your drill if you don't have oil running into it. Now this is a typical air filter regulator combination. They also call it lubricators and several other fancy brand names. But basically what they do is air comes in here, goes in, this is the regulator adjuster, which is going to control how much air gets out of the oiler when you're done. This is the gauge that tells you how much air is getting out. You're usually going to want this set up all the way, and that's usually turning clockwise as far down as it will go. And that's going to show you how much air this thing is going to let out. Often it's between 70 and 110 psi. If it falls below that, you're probably not going to run. 90 is a good range to start with. More is better up to a point beyond about 110 psi. The drill's not going to run any faster anyway, but more is not going to hurt anything. So, down here, a lot of them have either a filter or a water catchment, which is designed to dehumidify the air. Because especially in humid climates, compressing air tends to make the water fall out of the air, and it gets blown in here. And if you pull it out of this, it's better because the water in the drill tends to make the oil gum up and not work as well. Not a big deal, but it's usually there, so you can go ahead and use it. Now this is the important part, though. This is the lubricator. Now how this works, this here, which is usually an Allen wrench, is how you add the oil. You unscrew this and you put oil in here, in this hole, and you screw it back in. You can't do this while the drill is running because this is going to be under pressure. So you have to turn the drill off, get out of the hole, add oil, and then put it back in later. Now this other thing over here, this is your adjustment screw. So you're going to rotate this in and out, and that's going to control how fast the drops fall in this little glass thing, glass or plastic. And we're going to watch this now, and I'm going to show you how to adjust it. We're looking for one drop every 5 to 10 seconds. And that's going to change a little bit depending on how deep you are in the hole, because it's going to adjust your air consumption and other things like that. So just keep an eye on it and try to find a happy medium. It's not that important, but if you go too fast, you're going to have to fill your oil up all the time, and if you go too slow, you won't be having enough in your drill. So between 5 and 10 seconds between a drop is about what you're going for. So watch me do this now. Now I'm going to turn the drill on, so you'll hear that sound in the background. Now we're going to adjust this little knob here. Screwing it out generally brings in more oil, and screwing it in brings in less. Now you can see bubbles dropping right there. Now we're counting 1, 2, okay, that's too fast. We're going to slow it down a little bit. 1, 2, 3, okay, a little slower. 1, 2, 3, 4. 1, 2, 3, 4. Do that right there then. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's about perfect right there. Now, like I said, keep an eye on that and adjust it up or down as you need to. I have this set up with a valve here so that I can turn it on relatively close because my compressor is quite a ways away. I'm running about 300 feet of half-inch air hose to get it here, and that's why you don't hear the compressor in the background. Also, your regulator is going to be able to shut off your air supply as well, but I like having a backup here just in case something goes wrong with the regulator and just so I can control it.